Okay, I think this is working. So, hi everybody. Uh, my name is Greg. I'm here with my friend Antoine. Hi, Antoine.
Hey, Greg.
Hey. Okay, so this is a first for us. I mean, we're friends. We've been friends for a while, but I don't think we talk to each other in English over video. So we're very nervous, and we're very happy to be here. And the reason I don't know is this better? I don't know. So I think this is more like you see more of our beautiful backgrounds and Antoine's incredible mic setup and also all the weights that he has. So why are we here today? So Antoine is one of the, not to put you on the spot, I think best developers I've ever worked with. There, I said it. Um, I've always admired him. Um, he's always been, you've always not he, you have always been, very inspiring to see work, and especially when you're thinking about tech and architecting. And we're going to talk about web tech today, and I know you do more than the web, but there's enough challenges in the web stuff that it's an interesting thing to think about. But basically, yeah, when I've seen you when we've talked about architecting and we've talked about either like scaling and a lot of things and databases and stuff, like you've always really impressed me with how much you know and how much kind of you're seeing problems in advance in a very calm way, and you usually make your way around them very smartly. So I've always really enjoyed that. And we've had one conversation. There's one topic of conversation that's always really it's kind of obsessed me a little bit, and it still obsesses me, but I think today we get to finally, I mean, we're recording this, right? It's like the goal is maybe it will interest other people, maybe other people will also now be obsessed with this. I don't know if that's a good thing, but what I want to do today is talk about database serialization. Is that okay? I know you know, but is that still okay? Are you still in?
Yeah, totally. Yeah.
Okay,
Like,
cool. So okay, so I will just for everybody's, kind of context, whatever. Like I do some software development. I've done database stuff. I code some Python. Um, but I do it in a dumb, naive way. I think I make stuff work. I publish it on the web. I'm happy. I don't think too much about these things. They just kind of work. But I also like to work with people who think about them a little bit deeper than I, because they usually get me out of trouble or they just point out problems. So here is my point of view, and I would kind of maybe let's kind of maybe we can start a conversation here. My point of view is that you don't need to think about serialization, like whatever serializable stuff that we're going to talk about today. I think you don't need to think about it. I know it's not true, but I'm just trying to like get us to talk about this. So my point of view is like database transactions, which is like I think I know, right? So the fact that when you do like database stuff, and I usually use Django. I know you use more like SQL Alchemy, and obviously your SQL foo is more advanced than mine. But in Django, when I have like important database stuff to do, I might like remember there's transactions, and in my mind, a transaction is a safe way to do complicated SQL stuff, right? Like I'm reading a value and I want to update it, and I want to make sure, I'm not even sure, but that like somebody else isn't going to like read and write it at the same time as me. I'm a little bit confused, but in a way I would just go and make a transaction. That just feels like the safe thing to do. But I feel like that's not enough. And I'm not thinking about it clearly enough. And I want you to help me dispel that and maybe teach me. So I'll be asking all the dumb questions that are going through my mind. And hopefully you can help me. And hopefully this will help somebody else. So please help me explain, or please help me understand what's wrong about the way I'm thinking about it. And what am I missing? And what is serializable? And what are transactions? And what are databases?
awesome. Yeah. So I guess let's begin with like what. Yeah, I guess the topic of today is like isolation levels, more
Okay.
than like serializable, in the sense that serializable is one isolation level that you can choose from many isolation levels in database systems like PostgreSQL.
Okay.
And I guess we'll focus on the PostgreSQL today to avoid like going in many directions.
Yeah.
So like without any transactions,
Right.
if you just open like two connections to the database in parallel, and one connection, you read something, and then in another connection you write something.
Mm-hmm.
And then in the first connection you go back and read something again. Like you will see the updates from each of the connections all happening like at the same time as the lines are entered, basically. So
Mm-hmm.
like there's no isolation level, in the sense that every time you hit enter, if you are like manually typing,
Mm-hmm.
you will just see the results in both connections happening.
Mm-hmm. Mm-hmm.
um, for just like updating like a few things like that using like a terminal, most of the time it makes sense to just like go like that and not have a transaction open. But
Mm-hmm.
when you are dealing with other stuff, like for example you are buying a ticket, like I guess we can use
Right.
an example of tickets.
Yeah.
Let's say you verify if a seat is available,
Right.
then when it's available you buy it, like you reserve it. Let's say
Yeah.
yeah, let's say reserve. You reserve it. So in the same connection, like in the same flow of SQL queries, you would select and obtain that seat, basically, and then you will update that row to say like I reserve it.
Right.
Then let's say in two connections, like another one, someone else is doing the same thing at the same time.
Right. They're buying a
Like
ticket. Yeah.
yeah,
Mm-hmm.
exactly. Yeah, on the same at the same time, the two connections, or at the same time, almost at the same time, they check
Mm-hmm.
to find a ticket. They
Right.
find the same ticket, and then
Right.
since they got the same ticket, then they try to reserve it. Since you don't have any transaction open, then they will both write to the database that same row saying, yeah, I reserved it. So the
Right.
first one will say, oh, I reserved it for user ID ABC. And the
Yeah.
second one will just overwrite the change with, oh, I reserve it with user CDF, for
Oh,
example.
okay. Okay. So this is really good. And I think, yeah, you really said the context right, because I wanted to mention it and I didn't, but this is great. Yeah. Let's talk today about a ticketing system, right? Because I think there are kind of like simpler database things where transactions are like not necessary. And we could also talk about them, but yeah, let's focus on this case because it does happen. And we also happen to like maybe we're gonna work on a ticketing system together, which is a whole thing that I'm excited about. But right, so ticketing system has like sorry, and I know this is really obvious, but just to state it, and I'll be stating obvious dumb things from now on. Ticketing system, it's like if there's an event that has 10 tickets, you don't want to sell 11 tickets, right? If the limit was 10.
Exactly, yeah.
And so what is, and I know like this would probably help if we had like graphs and stuff. And the only thing that I can do is like this thing, which is not helpful. It just says welcome to the episode. But let's say I could like with my hands, like create database tables. So what are the table, like maybe let's even call the tables so we can kind of work through them, even if it's mental right now. So is this like one table and is there like one row per ticket? And to know how many tickets there are, you do like a select count. And then you're like, oh, there's 9 tickets, so I can sell a 10th one. Is that kind of how you're imagining it? Just to make sure.
Yeah, so far it could be that. Yeah, definitely.
Okay.
And also even like to go one step further, I guess. Let's say you just list the available tickets on the site. Okay.
Okay. So
And
select star. Yeah.
yeah, let's say yeah, select star exactly from the tickets available. And like let's say you have another SQL query that says like select count from tickets. So that you
Mm-hmm.
say like, oh, I have like 10 tickets available, and here's the list.
Mm-hmm.
Those are two different SQL queries.
Right.
And if while you are like selecting those tickets, another client will
Mm-hmm.
buy one ticket. So
Mm-hmm.
the first query would say like select tickets. You have like 10 tickets remaining,
Mm-hmm.
and then the other client buys the ticket. And then the next query, select star from tickets. You get
Mm-hmm.
only 9 tickets to show on the page. So like on the same page, you would show like we have
Uh-huh.
10 tickets available, and
Uh-huh.
then you will
Uh-huh.
list only 9 tickets available because you're not
Uh-huh.
within a transaction.
Right.
What you see is basically like everything happening live on the site while you're doing the queries.
Right. So it's like you're always getting the truth, but you're only getting the truth when that line runs. And obviously, we're talking about the problem of websites that have more than one user, which some of my websites don't have that problem, but many websites do have that problem. So, okay, this is becoming clear, but now I'll say the most controversial thing. Right, but that's what transactions solve, right? And I know the answer is no, but in my mind, if you like told me this and you did, I would go, okay, great. I really agree with you. If I'm selling a ticket and there's like obviously a chance that two people might try to buy the same ticket, I should do select count. I should check the number. And then if it's like less than 10, let's just say it's hard coded, then I can do whatever, like insert into purchase tickets or something, right? And that block, I just need to make a transaction. And if it's a transaction, if two people do it, something magical will happen and there will be no problems. But that's not true, right? And that's exactly the conversation today, right?
Yeah, exactly. Yeah. So by
It's
default, when you
yeah,
start a transaction in PostgreSQL, the isolation level that you get is read committed. Uh,
right.
in the sense that the example I just said, like you're getting things live as they happen. So like you could
Yeah.
show like 10 tickets available and only list 9 after that because it's been bought like between the two queries.
Yep.
Um, that's what you get by opening a transaction right now in PostgreSQL. If you don't set the isolation level, you get read committed. So that's the happening live. And the only benefit of doing that is that opening a transaction is that you could make many changes and they wouldn't be visible to other connections until you commit at the end. And if something
Mm,
goes wrong, then you could also roll back or abort
right.
and not write any of those changes to the database.
So that means that the read committed, and I guess this is just the stuff that like I haven't touched committed to memory because I've seen these like isolation like it's a list, and y- I think kind of the point of this call that I'm doing with you is like it's kind of important to know what they mean, right? You can't really use a database and not really care about isolation levels. Like, is that a good takeaway?
Yeah, yeah, definitely. Like at some point, the difference between some isolation level
Yeah,
becomes very subtle.
right.
But like I think that the one that you should remember is that like read committed, the default one, is definitely like not protecting you from updates happening at the same time as you are doing things.
Interesting. And so let's just go to read committed, and I'll try to state it in a way that like is simple enough that I'll understand it. So what you're saying is while I am reading the number of tickets and I decide, even if it's incorrect, but if I decide to like insert that ticket, it just means that other people are not seeing my insert until my transaction is done.
Exactly. Yeah. Yeah.
I see. So, okay. Well, so, okay. But that doesn't work for tickets, right?
Exactly.
Because,
Yeah, doesn't work for tickets. And like the use cases for that isolation level
yeah.
is like to me is really like for stuff that is not that important. Like if you were to write a bunch of logs or analytics or things like
Hmm.
that,
Hmm.
like it's not that important. You're just like writing, and what you want is performance more than like
Hmm.
uh, truthness in the data.
Yeah, yeah, yeah. Right, right, right. Um, I mean, it's kind of ironical in a certain way that like the read committed one is really good for writing. Um, well, writing that doesn't take into account other things, writing that doesn't take into account reads. I'm still trying to come up with like just like an easy mnemonic for me to remember. But okay, so I accept that read committed like doesn't work, right? Because if we just walk through the exercise, if you have two read commit transactions, first of all, they could still be happening at the same time. Is that accurate? Right, they would still like be
Yeah.
like right, and they're like both within transaction bubbles. So like the fact that I'm inserting in one is not going to affect the other, but they could still read at the top of their individual transactions. There's one ticket left. They could both decide, great, and they could both insert that like purchase ticket. And at the end of both of those transactions, you still end up with 11 tickets sold. Is that accurate?
Yeah, yeah, definitely. And also, like in that case, even if you're using the transaction,
Yeah.
let's say you read those like the count, you have 10 tickets available, and
Yeah.
during that time, another one comes there. Like you both open transactions,
Yeah.
and then during that time, someone else comes and they buy a ticket and
Yeah.
commit.
Right.
Then in your own transaction, you see those changes happening anyway because they've been committed in that other transaction.
Uh-huh.
So it's not protecting you even like if you are both in transactions.
Right. Okay. So that sucks. Okay, so we're not going to build our ticketing platform with that. And this is the little PSA that also was really interesting is that we got started and I was like, let's use Django. I love Django and I will absolutely still build a million Django projects from now on. But you who typically like don't necessarily work with Django, even though I think you respect it, but don't answer it. Fine if you don't. But I think you do. But you were surprised, right? Like you're kind of the moment that we had a conversation. You were like, hey, like you use Django, like you set up the models. We were like trying to do this ticketing thing, like just an MVP. And then you were saying, wait a second, the default installation level in Django is not the thing we're going to talk about now, serializable. And you said actually Django seems to like not really help you when you try to do things like more correctly, like the way that you need to do for tickets. And then we kind of got into a weird, like we were like, huh, like maybe Django's not the best for this. So maybe I'll leave out the conversation about Django because I'm not fully sure. Maybe some also super smart people who like know Django really well, way better than I do, have figured out the Django serializable thing. But just like PSA, right? Like something about Django, like a default isolation thing for ticketing platforms. If you happen to build one, just like take note that something could happen that you wouldn't expect. Okay, so let's exit Django. Let's just talk about back to like Python, even if it doesn't matter, but most probably SQL, databases, and then the answer to this, right? Which is like the other isolation level, which is called serializable. So can you explain to me what serializable? You've convinced me that read committed is not the right choice for tickets. What should we do? And again, I know the answer, but what is it and why?
Right. So there are many isolation levels.
Right.
Read uncommitted is one of them. Sorry, yeah. Actually, there is read uncommitted, which is like in PostgreSQL, it's not even supported that much. They just use read committed.
Mm-hmm.
Then you have like read committed, and you have repeatable read, and you have serializable.
Mm-hmm.
Um, so in our example of like
Tickets.
buying tickets,
Yeah.
let's say you select the number of tickets and you open transactions like you have two clients opening transactions, and like in the first one they both use the serializable isolation level, which is the strictest one.
Mm-hmm.
In the first one you select the count of the tickets, you get
Yep.
10, and then in the other transaction they buy a ticket, and they commit the
Mm-hmm.
transaction. But
Mm-hmm.
in the first transaction where you got the count of 10, you continue, you select all the available tickets, you will
Mm-hmm.
get the 10 tickets because they
Mm-hmm.
are isolated, and you don't see the changes from other transactions while you are in your own transaction.
Mm-hmm. Mm-hmm.
Same with a repeatable read. Basically, you are in your own frozen in time
Uh-huh.
view of the data.
Yeah, yeah, yeah.
Uh,
Can I
and
just
then,
can
yeah,
I
go
just
ahead.
change the example so that there's only one
Sure.
ticket remaining? It'll just be easier for my brain, if that's
Oh
okay.
yeah, totally. Yeah, yeah. Let's
Okay,
do that.
cool,
Okay,
cool,
yeah.
cool. Okay,
You select the tickets, and you get a count of like you
nine.
have one. Yeah, no.
Yeah,
Okay,
nine
okay,
remaining. Yeah,
okay.
one remaining. Yeah,
Okay,
sorry.
one. Yeah, one remaining, and then you list the one remaining, and the other
Yeah,
one you buy the ticket.
right.
So the first transaction, the first transaction that got the count and listed all the tickets, which is just one in that case,
Yep.
you still get that picture of the world that happened when the transaction started.
Uh huh.
So you show that on the page. It all happened at the same time, basically. So there's like it's kind of true that like that there's one ticket remaining,
Yep.
and then the other one could buy the ticket, no problem. And then like let's say the user, like the first user, refreshes the page, they'll see like a count of 0 and no ticket remaining.
Yep.
So at that point in time, when you started that vision of the world, let's say,
Yeah. Yeah. Yeah.
you had one ticket, and like the data is consistent. Basically, you get
Right.
like a full picture, and even if you continue to do things like for like 1 minute, you would still see that picture in time of how the data was in
Right.
time.
Yeah. That
So
makes sense.
that's yeah. So far that makes sense. Okay, now let's go back to the case where two users would buy the ticket at the same time.
Right. Yeah.
So
And
let's
it's
say
like,
like
and
yeah.
we're talking about the same time. Sorry. Like, let's just say, right, like really one's begins like 10 milliseconds later, and both take for some weird slowness of whatever, like maybe they take about a second, but they are really like two contiguous blocks of time. One is just slightly shifted in the future. That's okay.
Exactly that.
Cool,
Yeah,
cool,
yeah,
cool.
exactly that. Yeah, yeah. So first, client tries to buy a ticket. So they select the tickets to see like how many tickets are left, something like that.
Yep.
And then the second one would be like, okay, I found one, so I will buy that one. So you update that row to say like that ticket has been bought by that user, for example.
Yep.
Same thing is happening on the second thread. Basically, the other client trying to buy a ticket at the same time. So they select the
Yep.
tickets. They see one ticket because they do it at the same time. Basically, like the first one tries to find tickets, they get
Hmm.
one,
Hmm.
and the other customer that wants to buy a ticket, they select tickets, they find one as well. So that they're trying to buy the same ticket at the same
Right.
time, basically.
Right. Right. Right.
And then let's say the first one, the first like first customer, like the
Mhm.
machine was a bit faster, for
Yeah.
example,
Yeah.
and commits the change, the first one.
Yeah.
So then like the second
Yeah.
one, the transaction will just fail. It will reject the transaction. When you try to commit, it will fail. So like the responsibility of handling that failure is in the code, like the Python code, for example.
Right.
It handles that. So like in that case, if you didn't do anything, like the second customer would probably just see like an error page,
Right. Like
and
a
you don't
500.
want that to happen, obviously.
Right. Right. Right.
um,
Right. Right.
so
So
in
you.
the yeah,
Mhm.
go ahead.
No, no, no. Please, please. Yeah.
Okay,
Yeah.
yeah. So in the real like application, what would
Yeah.
happen is that the Python code in that example would just go over like that section of code, like start again and like find a ticket and try
Mm-hmm.
to buy a ticket. But then like, oh, it could not find a ticket this time, because
Mm-hmm.
like then like it's in the world like past
The first
the first.
transaction.
Yeah, exactly.
Mm-hmm.
So then
Mm-hmm.
it would return something to the user saying, oh, sorry, like that ticket has been bought while blah blah blah. So it's not
Uh-huh.
available anymore.
Okay. So it does the right thing. It raises an exception, which, like in Python, like there's a whole ethos about, like, it's good, right? Like we want exceptions, we want things to be clear, and obviously, like you would catch it. I I'm a little bit curious. I mean, I'm curious about a million things here, but like, is it accurate to say that this, like the failing transaction, the second one, right, the one that's a little bit slower or just came a little bit more in the future, um, is it failing on the, like, the update or the insert? It's not the selects that is gonna make it fail, right? If you have 2 blocks of transactions and they just select stuff, there's no, like, isolation thing,
Exactly. Yeah, yeah.
right?
Well, there's still isolation in the sense that you still get a picture of like that data in time.
Right.
But then, yeah, definitely, if there's no update, there's no chance that transaction will fail. It will just succeed.
Uh-huh.
Yeah.
So, like, right, so, like, the two transactions might both, like, do a select star and got it, right, and I mean, they're right, if they start a little bit later, if there's 9 rows, there's still 9 rows, it kinda doesn't matter, and they're isolated, okay, that's good, just, again, trying to, like, rephrase this. But, obviously, an update, an insert, whatever, like, it is changing the database. Is that, and and sorry, like, I don't mean to be like, let's look into Postgres source code, because I don't think then we'll emerge from that rabbit hole. But is it truly like there's a categories of, like, SQL verbs or commands or whatever that, like, affect the database, and those are the ones that are like that Postgres watches or uses to determine whether it's going to break other transactions? Like, what is the real, like, trigger point of, like,
Yeah,
the
so yeah, to that point, I'm not sure like how in Postgres it's implemented, but I would
yeah.
think that like when you update something, it marks the data as being updated, and then if you
Mhm.
try to like write on something that's been updated within that transaction, then so I think it's not like that much about like the SQL that you wrote, but
Uh-huh.
more
Uh-huh.
about like the data in like the tables and the rows.
Right. And then, of course, there's like a whole other topic, which is more hyper, like, hardcore intense. And I'm sure there's, like, beautiful articles about this. Sorry, everybody, that I didn't do my research, but I'm sure there's, like, thinking about whether it's the whole table that was affected or certain rows, right? Like, because, like, is it just like, oh, anything changed in the database, I'm going to make all transactions fail? I'm sure Postgres is smarter than that. But is it like seeing only, like, which columns change, or is it new rows or whatever? We're not going to get into it because I feel like it's too much. Um, but what you're saying is, like, just back to the kind of, like, the core point of this is that, like, Serializable does the right thing in that it breaks your transaction specifically by saying, hey, you expect, like, I gave you a vision of the world. You were operating in that vision of the world. You kept doing stuff inside of your transaction bubble, But while you were doing that, the world changed, and in a significant way, like the data changed, whatever. It changed, and so your preconceived notions are wrong. It's just kind of like maybe somebody who's arguing with you, and they're going off from a wrong fact, and you just kind of go like, "You actually that was all wrong. You thought you said something at the top. It's all wrong. So you're all wrong." That's not a good way to have a conversation. But in the case of the transaction, it just gets killed. And then, do you like what does the exception look like? I'm just curious. Is the exception like super generic and it just says like, is it just like error? And you're like, okay, or is
Yeah,
it
no,
like,
it's
yeah,
it's kind of clear. It says that there's a conflict in like the transaction could not serialize or something like that. So like
mm-hmm,
it's
mm-hmm,
specific about that, and usually in like the libraries that you use to do SQL, like SQL
yeah,
Alchemy, things like that, they catch that and they raise like a specific type of error that you can catch and retry.
and handled, which is different than
Yeah,
like you couldn't connect your database because of
yeah,
a network
exactly. Yeah,
failure.
yeah,
Okay.
yeah.
Okay, this has been really great, and I want to part with one last question. And thank you so much for your very generous explanations. It's been really great for me. I hope it's been nice for others. Um, I want to know whether every single project I do now should use Serializable, because it feels a little bit like, hey, it does the right thing. Sure, I'm not working on ticketing systems all the time, but I'm annoyed at the idea that I might be like select and inserting wrong things. Like, I don't want it to be convenient, but also like weirdly do subtle errors. That is the worst kind of errors, the subtle ones. I want obvious, glaring, gigantic errors, right? I love exceptions because they mean there's a problem that I get to fix. I don't want corrupted data. So I suppose there's going to be a performance thing, but let me ask you still, would you say everybody should always use serializable all the time? Does that just solve, I mean, that kind of problem? So it's not even worth not doing that.
Yeah, so well, definitely, like it's a easy answer, like no, like you shouldn't use it all the time.
Right.
And however, I feel that PostgreSQL having the default of read committed as the isolation level is could be changed to like I feel like it should be changed to maybe serializable,
Uh-huh.
in the sense that like like when you start a small project, you want correctness first,
Yeah.
and if you then have like specific things about your project that you want to um, forgo that, like abandon for give up for sorry, give up correctness
Right.
for something else that you get, like performance,
Right.
or yeah, performance would be a good one. um, then you make the decision, like
Right.
I explicitly say I don't care that much about correctness. I
Hmm.
want performance for my use case.
Hmm.
um, so like I feel like when you start a project, if you know that like you won't have like a huge spike in traffics and things like that, personally I would use serializable if
Hmm.
like it's easy to use with like the framework that you're using, things like that.
Right.
um, and then like you go down in isolation level, like it makes sense depending on your
Hmm.
project.
Hmm. Interesting. And so, and performance, like clearly transactions failing because the database changed, like clearly there are situations where either it doesn't matter, or as you're saying, you can handle it because you can put in more thought. But it is a little bit true. So I guess, yes, of course, to answer, like, should it always be for everyone forever? The answer is no. But it would make sense that you're agreeing, right? What you're saying is that as a default, as a safer default that you break out of consciously because you know that you can remove the safety of it, rather than being in a less safe place that's a little bit more performing, but it's also more confusing. And it can be more confusing to people like me who don't really think super deeply about these things and just want to make weird projects really quickly. You feel like there should be a little bit more safety for by default. Is that safe to say?
Yeah, that's my feeling. Like in general, I care more about correctness, and if I want to build something that like needs more performance, then then like you figure something else, because like if you still need correctness but more performance, then you may go down in isolation levels, but like build an architecture that's bigger, handling like things differently. And yeah, and also like at that point you may consider like other data stores that are like key value stores, things like that, that could be even more performance maybe, or like more distributed, things like that. But then like you get into another world of like having many data stores, and then how do you distribute transactions, things like that. So like to me, like the default for most projects is that like you have a single database that you can scale up vertically. And that's why I think you should have like the best isolation level when you're working with that. And then like according to the needs, over time you can like start to degrade, I would say, like the isolation level. And even then, like you may decide that only specific things in your project require other isolation levels. So for example, in the example of the tickets, you may say like, I don't care that much about the comments on the event, for example, like maybe those can be less strict, but when you are buying the ticket, that one specific transaction, you want it to be serializable. So depending on like the page or what the user is doing, you may decide on different isolation levels, and they usually play well together. So like the one that says like read committed can still work while the other one is serializable, for example.
And you can set them like per transaction, right? You mentioned that earlier.
Exactly. Yeah, exactly.
Okay, that's awesome. So it's not just you're going into like postgres.conf and then you're like,
yeah, no, it's definitely per transaction. Yes,
it's per transaction. Okay. Again, smart people have thought of this. Okay, I think this is great. Half an hour, we did it. We explained everything. Everybody now knows more, thanks to us. So, wow, we're just so awesome. No, this was really fun. I'm really grateful. Maybe this will be one of many. Maybe this will be one of one. But thank you so much for taking the time this morning. And
You're welcome. Thanks for having me.
Yeah, that's great. Goodbye, everybody. Leave comments. I don't know. Email us. Whatever. Do good things. Do good work, but just use Serializable if it fits your use case. Okay, bye.
Thank you.